This question involves graphs. So the first thing we're going to do is analyze the graphs before we even read the question. And our first tool we'll use is our Oyzerga. So we have Oyxirga. And so our origin, we see 0, 0 in all four cases. And so this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So that means all the velocities are positive and the times are positive. Our y-axes for all of them are v, so the velocity. The x-axis for all of them is t. So all the graphs are comparable. The next thing we want to look at is the intercepts. So in the first graph, what we have here is a v0 equaling a large value, and it's positive. And down here, at this point, it means we have a v equal to 0. In the second graph, however, we have a v0 initial velocity being 0 and ending with a velocity equal to 0. Third graph, we again start with v0 being a large value that is positive, decreasing to a v equals 0. And the last graph, we again have v0 equals 0. And we're ending up with v equals 0. So right away, just looking at the intercepts, we should see that it's broken down into two categories. The first that has a large values for the starting velocity, and the other one's 0 values for the velocity. So that's our intercept. And we look at read, well, the read is the actual axes, so we can read velocity and time. The gradient or slope then is dividing the axes, or delta v over delta t, which is the definition of acceleration. So the slope is the acceleration. And the area is v times t, which is meters per second times seconds. And so the area is the displacement, delta x. All right, so an object is thrown upward. So let's first create what happens when we throw something upward. If we have a person like so, and that's a tree, of course. You recognize that being a tree. Person is standing on the ground, and they throw something upward. Well, let's see. Since the graphs are about velocity, what do we know about the velocity when something is thrown upward? Well, it slows down, and at the top becomes 0. And on the way down, it speeds up. And when it returns to the same height, it will have the same speed. So in other words, at the very beginning, the velocity will be a maximum. So right away, because we know we did our intercepts in the beginning, that tells us that these two choices are out. These are out because it says the velocity starts at 0, when in fact, it starts at a very high velocity. So we're at 50-50 right there, just recognizing what the meaning of the intercepts are. Okay? So now what we see for both A and C is that we see that the velocity decreases to 0 and then increases again. The difference between these two has to do with whether or not the function is straight lines in choice A, or whether it's curved. And so what's happening there is a change to the slope, which is the acceleration. Well, when we think about this ball being thrown upward, the acceleration is caused by gravity, which we know to be about 10 meters per second squared. And we know it is constant for the range of normal human occupation of the Earth. For normal humans on Earth, that means from all the way down in the bottom of the Marianas Trench all the way up to commercial air flight. Although we can measure differences, none of us would notice a difference. And we couldn't measure differences with the equipment that we have in our physics lab. So in other words, the acceleration should be constant, and that's the slope. And that's why choice A is the answer.